air has mass, okay? And as we've seen, it tends to operate in big chunks. Now, within a chunk or an air mass, you're going to have some fairly consistent properties: the pressure, the temperature, the humidity, the amount of water vapor, etc. And so scientists, meteorologists, here's how they've grouped air masses. Notice the color scale. We got light blue for polar, meaning cold, and then the really cold stuff is the Arctic, which is the darker blue. Then we have the warm, and then the warmer, the pink, and then the darker pink, going almost to red. Now, you take the temperature and then you add in the idea of, is it over the land or over the ocean? And then we got the various combinations that are covered in the textbook. We're going to use the word maritime for air masses that are over the ocean. And we'll use continental for air masses that are over the land. So right there in the middle of the Atlantic Ocean between North America and Europe, you see little baby m with a capital P. For maritime, we'll use a little baby m. And for polar, we'll use a capital P, MP, maritime, polar. We're going to use a little baby c for continental. Kind of like what hit us last week. We had a continental Arctic, capital A for Arctic, drop down and attack us. That would be the dark blue, similar to what's shown over the Hudson Bay and Greenland in this picture. Okay, again, baby M for maritime, T for tropical, capital T for tropical. Where we get a lot of our hurricanes from. Look way over to the right-hand side. You see an MT. Get lots of what are called typhoons, aka hurricane, from these. But there's also continental tropicals, and then you've got M for maritime, and you got E for equatorial. So it's just a way of classifying the various air masses.
Professor?
Yes, ma'am.
Why isn't there a continental equatorial shown at all?
Who's the guy that made this map got lazy, I think. There would be a continental equatorial, for example, over the northern part of South America.
Okay, so they do happen continentally, not just in the ocean.
Right. The idea here in this picture is to give you examples, but not to be exhaustive in all the examples. Similarly, there's not a maritime Arctic, but if you were over in the Sea of Okhotsk, you could very easily get a maritime Arctic air mass.
Professor, quick question again.
Yep.
At the bottom on Antarctica, there's
I don't know why there's two A's.
Okay, like it's very, very frigidly cold.
It's probably a typo on the part of the guy who created this drawing.
Probably needs a proofreader then.
There you go. Guess what? Air masses move. Kind of back to this picture. Well, when those air masses collide, we get this thing called fronts. Can anybody tell where the front is in this picture?
At the cloud line?
There you go. I actually took this picture. I was up on the roof of my house. I forget why I was up there. It was a cold, wintry day. No, we didn't have snow, but I looked up and I saw this and I said, "Oh, I'm going to get that picture so I've got it for class." Yes, it's very obvious where that front is. Well,
But
guess what?
how can we not be sure that it's at the back? Why does it have to be the front?
Leave the comedy to the Bears. All right. Anyway, guess what?
Oh, Burn, she got you.
Oh yeah. And you know what? That's my daughter. She owned it. She owned me. Alrighty, let's talk about cold fronts. I like
Wait,
this
did you
picture.
just say that Megan is your daughter?
Megan is my daughter.
She calls you professor. Does she call you that at the house?
Nope.
Oh, that'd be cool if she did, though.
Yeah. Just don't call me
My
late
wife,
for supper, okay?
my wife teaches our daughter, and my daughter insists on calling her mommy in class. I mean, she's in K5. She's in K5, granted. So other kids have started calling my wife mommy as well because Heidi calls her mommy. No professional courtesy spared at all.
Well, I have a very amazing daughter, and she's maintaining professional courtesy during class. Alrighty. So remember that chart I showed you of all the different types of clouds? It had shorthand for the different names. Guess what? Those get used in this picture. Notice CI for cirrus, CS for cumulostratus. This is cool. So, cold air. Could be polar, could be Arctic. Don't care. It comes zipping along and it hits a warm air mass. Energy transfer happens. Warm air rises, cold air sinks. We got all kinds of motion going on. Generally, cold fronts bring your most severe weather. You ever notice when a thunder bumper starts coming in, you get a big temperature drop, and then you get the rain and the thunder and the lightning and all that fun stuff? That's what's going on. Similarly, you can have the warmer mass zipping along and it runs into a slower moving cold air mass. This would be called a warm front. And look at the kinds of clouds it produces. Nimbostratus, altostratus, cirrus clouds. George, you probably get a lot of these because you typically get precipitation that lasts long. You get long, slow rainstorms, I suspect, right?
Yeah, well, my wife, like every foreigner that moves down here has the video of their first thunderstorm, and we all laugh at them because they last so long and the drops are so big and it's very, very loud and it's very, very heavy. But Professor, I like one of the things you talked about the ocean and the winds and temperature and the fluxes and all that. We're in a
Yep.
very particular situation because we have like the Pacific and the Atlantic Oceans are super close to each other. So this must be a mess. Like I can't even imagine what it looks like from a meteorologist's point of view.
So maybe the meteorologist there, the job isn't quite so boring.
Right?
Yeah. There's another type of front called a stationary front. That's when the warm and the cold sort of run into each other and they sort of stall out and you can get some pretty horrific weather. And it may just sit there for a few days. And there's this other kind of front called an occluded front. Kind of similar to a cold front. But it's when you get a warm air mass caught between two cold masses. And the colds go under and the warm gets shoved up. So, Joseph, as you pointed out earlier, there's a whole lot of stuff interacting here to create weather. But the foundational principles are actually fairly simple. The way they play out gets complex, as George has pointed out.